I'm Samhitha. I'm a full stack engineer at BlackRock, and here's a little something about me. Before we get started, let's do a quick icebreaker. If you could please scan this QR code or go to menti.com and enter the access code, that would be great. And no, it's not a survey, and if you love judging people, you're gonna enjoy this. Let me start a timer for 30 seconds. All right, let's see the responses. I don't think you're able to see it, but I see that a majority of you have chosen the second option. Well, it is actually true that I cannot swim for my life. So thank goodness I did cage shark diving in Hawaii. Otherwise, I couldn't have gotten out of there alive. And what were you thinking, not even picking the first option as the obvious lie? Do I even look like I can bench 30 pounds? All right, let's get started. Imagine you are building access control into your web application. The first question that you'd probably ask yourself is, what strategies should I use to make sure that sensitive data is accessed by only those who truly need it? Then you might start thinking, should I implement it at the component level or at the API layer? Or is it safe for the backend to handle it all? Then you might consider another layer of complexity. How do I integrate all these permission checks with business logic and feature flags so that certain features are only available to specific users? So by now, I hope you realize that access control is not a single decision, and you'd have to think through multiple layers in your architecture in order to get it right. So how do we do this? In today's session, we are going to go over all of this and explore two ways to implement access control. That's granular, dynamic, and scalable. Why should you care about it? Before I get into that, can I get a quick show of hands if you have already implemented attribute-based access control? Or you can say, I don't know what the heck you're talking about. All right, now raise your hand if you're a Breaking Bad fan. That's my tribe. Okay, why should you care about it? OWASP has listed broken access control as the #1 security risk in web applications. And they also recommend attribute-based access control, or ABAC, over the traditional role-based access control, which grants access to users only based on the user's roles. Why? Because it's more effective in implementing the principle of least privileges, and it also handles dynamic access needs. Let's see how. Consider Sam, who is a publisher for a blogging application. When she joined, she was assigned categories within which she could take actions. The access control rule is that publishers can publish approved posts in their assigned categories, but only during the business hours. Whenever a blog post is created, it is given a certain category. It is initially unreviewed, but eventually gets approved by the editor. Now, if Sam wants to publish this post, access is granted not just based on her role, which is the case with role-based access control, but also based on her attributes, the attributes of the post, which is the resource, and environmental attributes like time and location. So these three components, along with the policies themselves, are the 4 core components that make up ABAC. Now, if any of her attributes change, like she moves to the membership department or is assigned to fashion, her access is automatically revoked. And because all of these attributes are incorporated into the decision-making process, your application's security is much, much more robust. Where should you enforce it? You would enforce it in the front end so that users have immediate feedback. They instantly know what they can or cannot do, and this makes for a very intuitive UI. But it's only the first line of defense. It's like hanging a do not enter sign on your door and not actually locking it. So it's very important that you also enforce it on the back end, because front end access control can be easily bypassed with the right tools. Also, notice how I'm talking about permission or access control enforcement and not permission definition. That is because while these enforcement or checks need to be performed on both the front end and the back end, the definition of the rules themselves need to be on the back end as a single source of truth. This is so that the same access control rules can be uniformly applied across all backend services and multiple front ends like your web and mobile and so on, and without any rule duplication. So how do we build an access control solution that satisfies all the criteria that we discussed so far? We'll be going over two solutions, like I said, and the first one is CASL. It's an open source JavaScript library which allows you to define permissions in a declarative manner, like what the user can or cannot do instead of worrying about how to check for permissions. Consider these examples from our blogging application. An admin can manage everything. An author can create and edit their own posts within their assigned categories, but cannot delete published posts. These are called abilities in CASL. Let's convert this into code. Begin by defining a function called defineability for, which takes in the user as an input and returns the user's abilities. If the user is an admin, the user can manage all. Manage and all are keywords in CASL, where manage is any action and all is any subject or any resource. If the user is an author, the user can create a post but cannot delete a post. You can also type check these abilities by defining a type for actions and subjects, and using the defined type to create an app ability object. Also notice how there is a create Mongo ability function that's being used here. It does not mean that your application has to use MongoDB. It only means that we'll be using certain operators from the MongoDB query language. One such operator is the in operator, which is used to specify conditions on the abilities. The user can create a post but only in tech and lifestyle. Or the user can update only the title and description fields of their own posts which are still in the draft state. If the description object is nested, you can use a wildcard to specify that you want to grant access only to the top level fields. And you can use cannot to specify what the user cannot do, like deleting a published post. So behind the scenes in CASL, all the can rules are combined using logical OR, the box in green, and all the inverted rules or the cannot rules and the conditions are going to be combined using logical AND. Okay, so remember this, we have the defineability for function which takes in the user and returns the user's abilities. Because the permission definition needs to be a single source of truth, this is going to be a shared library between the UI and the server. Once the user is authenticated, you would call this function, pass in the user and get the user's abilities. To validate an action on the server side, you would use ability.can and pass the action and the subject. The same ability.can function can be used on the front end to perform programmatic checks. Better yet, create a context and provide the ability instance to the app so that all the components in the app have access to it. CASL also provides an option to create a contextual can component. You must be wondering who this artist is who cannot even draw a straight line. So you have this contextual can component which you can use as a wrapper around other components for conditional rendering. Do you see how readable the permission check is? Can I delete a post means that you are asking if you have the permission to delete any post, because post here is the type of the subject. Can I delete this post means that you are asking if you have the permission to delete that particular instance of the post. I know it's a tad confusing, which brings me to my next point. Should you be using a third-party library? While they offer a lot of convenience, there are some concerns about using third-party libraries in enterprise applications, especially the ones dealing with sensitive data. Why? Because the documentation could be unclear, inaccurate, or outdated. But most importantly, there may be vulnerabilities in the library itself. So to have complete control over your security logic, you may want to build your own solution. You might want to pay attention to this section because at the end of it, there is going to be a question with a very cool bonus. So how do we write the policies such that it can be used by both the UI and the server? We'll be using policy as code, which means that you're going to use code or configuration files like JSON or YAML in order to define and manage the policies. The benefit is that the policies can be version controlled and it's also easier to scale. This is what it looks like in YAML. We have two policies here, each with its own condition. If the condition evaluates to true, it means that the policy is in effect. The effect field determines if the action on the given resource is allowed or denied. The conditions themselves are written using Google's common expression language, which is supposedly very fast and secure. I do not like the structure of these policies, so let's redefine it. When you group the policies by resource and action, you make it much easy to navigate, and it's also easy to track and add new policies under a particular resource. And even with growing policies, the lookup time is going to remain constant. Okay, we have the policies in place. How do we evaluate the conditions? There are CEL evaluators available for different languages, but for the front end, we'll be using the Cell JavaScript evaluator, which takes in the condition and the corresponding objects like the user, resource, and environment, and it produces a Boolean output. This evaluator or the validator is going to reside inside the web app, and it's going to get the resource and environmental attributes from the component invoking it. Now remember, we also need the user attributes and the policy for ABAC evaluation. Once the user is authenticated, the user details like role and department are also going to be stored in the global state and is going to be read by the evaluator. The policies can be fetched from a policy management service. I'd like to use Redux Toolkit or TanStack query in order to conditionally invoke the get policies API after a valid user ID is present, so as to avoid unnecessary network requests. And because we are using Redux Toolkit or TanStack query, these policies are going to be automatically cached in the store. But please be very mindful of storing sensitive policy or user information in the store. For the purposes of this example, I'm going to be reading it from the store, but if you'd like to persist it across sessions, there are other ways to do that. Now, more often than not, even if you have the permission to perform an action, you may still not be allowed to do so because of contextual business logic. And this logic may depend on the state of the application and may need to be handled dynamically. So what contextual rules are these? Some examples would be to prevent the approval of a post if it is still being edited, to disable the comment button if the comment is not yet typed into the text box, and to prevent the creation of a post category if the name already exists. So if a contextual rule is present, the output of the policy validator is going to be combined with the output of the contextual action validator. Encapsulate all of this logic inside a use permission custom hook that would be used by any component that needs to check for permissions. So that with changing application state and changing attributes, your hook would recompute the validation output and in turn trigger a re-render in all the components that use it. This is what a high-level simplified code for the use permission hook looks like. We have the validate permission function here, which handles the cell.js evaluation. And if a contextual action rule is present for the given resource and the action, the output of that is going to be combined with the output of the policy based evaluator. Otherwise, only the policy based permission output is going to be returned. Okay, now here comes a question. Please raise your hand if you know the answer, and the first person to answer is going to get an Amazon gift card. There is one thing in this code that most definitely needs to be improved. What do you think it is? Something that has to do with performance. And you'd still be able to answer it if you zoned out for the last 15 minutes. Yes, please.
Probably need some memoization somewhere in there?
No. Sorry. Anybody else? Yes? Sorry, I couldn't hear you. Not quite. I have commented it that errors need to be handled. It's something else. No.
Can I reel out a list of things until you tell me which one is right?
What's your first choice?
I don't know, remove the use select.
That's kind of close, but instead of removing, the problem is actually with the usage of the use selector hook. But not remove it entirely. The problem is with just the usage in terms of how we are using it. You see here that I'm subscribing to the entire freaking application state, which means any state change is going to trigger a re-render in all the components that use this use permission hook. So your use selector needs to be as granular as possible and subscribe to only what's necessary instead of removing it altogether. Okay, I'm not able to see your faces clearly, but I'm gonna take a shot in the dark and say some of you look very relieved because I've already added this meme on my slides. Moving on to the last bit, we looked into how to define the permissions for a custom solution. How do you enforce it? You can create a CAN wrapper component inspired by CASL to hide or show a component, to disable a button or any other component, to create a protected route. So if the user has the permission, you would show the outlet, otherwise navigate to the login page. And lastly, to skip an API call. That almost wraps up our session. Let's summarize. So you learned two ways to enforce fine-grained attribute-based access control, one using CASL and the second using a custom solution. Both are scalable in terms that adding a new policy means updating only a single file, which does not require any code rewrites. They are dynamic because they work seamlessly with changing application state. They're readable because it's conversational language. Can I read a post? And they're clean because there is separation of concerns. So that was quite a bit, but if there was one thing that you remember from this session, hopefully it's not the fact that I choose to bench 30 pounds as just a warm-up, but consider using OWASP recommended attribute-based access control. It's more effective in implementing the principle of least privilege. Let me add a couple more takeaways. Your policy definition needs to be a single source of truth, either as a shared library or as policy as code. And lastly, evaluate your access control criteria in the back end for security and in the front end for reactivity and usability. I'd love to connect with you all on LinkedIn, and if you like this session, feel free to DM me for a free handbook that covers all the details and much more. Thank you all again.